So let's pick up where I left in the last video. So I showed that we could approximate the potential in our periodic lattice by this block theorem, where my potential is defined as these set of delta functions. So my ux is essentially it's a constant time this delta function, where my potential also has this periodicity of my lattice constant. So my potential at a point of x is the same as the potential as point of x plus a. And what this result is that now, as a consequence of having this periodic potential, I determined that my wave function, which is this phi k, will be of this form of a small uk into multiplied by this exponential e to power iota kx, where again what I get is now since this function is of this form and my small uk also has a periodicity of a. So what I get now is my wave function at a point of x plus a is related to my wave function at this point of x by this simple relationship. And then I also derive that whenever I have this set of delta function, I have this potential energy 0 over here, and then I have an infinite barrier over on the edges. So in that case, I could write my the equation of my the solution of my Schrodinger equation. It comes out to be of this form. So now the only job I have left is to find out these value of these coefficients, how these a and b are related, and then I'm done. I get whatever I get out from this solution of finding a and b has to be my band structure. So what the condition that I'll use is I'll use the same boundary condition that everybody in quantum mechanics uses, that my wave function has to be continuous at a boundary and my derivative of my wave function has to be continuous at the boundary. And then I have this extra relationship that I can leverage, that is my wave function at a point x plus a is related to my wave function at point x by this simple relationship. So I do that, and what I do is essentially I can relate my in this case what I've done is related my my wave function at a point x minus a to my wave function at point x, and what I need to do is essentially equate them and match the coefficient on both sides. So what I get is these set of relationship, and I'm again stating it over here, but I've followed the same convention, and I've followed the same methodology as Paul Frey's book. So you can go over and look that, and you can do it an exercise that try to equate these functions at point of x and x plus a, and match the coefficients on both sides. So if I match my wave function, I get from this boundary condition on my wave function, I get this relationship where b is related, a and b are related in this fashion. And similarly, if I match the derivatives, I get this relationship. And again, you can look at Paul Frey's book in case you're not having difficulty deriving it. So now what I can do is relate, so I have two variables, that is my a and b, and I have two of these equations which come from my boundary conditions on my wave function and its derivative of the wave function. And so what I get if I solve for a and b is I get this condition where I've separated the terms of k and g. So if you look at the left hand side, this is essentially a relation just in terms of k, versus if you look at your on my right hand side, this is all related in terms of g. And g, as we postulated earlier, essentially this it was related to my to my to my energy in this particular fashion. So now this is starting to get exciting. I know that I'm very close to the finish line over here. What I've done is I've derived this relationship which relates my energy to my momentum, or k, and they're related by this very simple equation. The term on the left hand side is essentially a cosine function, so we know that this has to be between -1 and 1, and then we can plot this function out. So what I've done is plotted this function out, and essentially if you take another closer look at this function, this essentially relates my this term is just related to g, or is just related to energy, and it's given by this cosine function which is periodic, and then it's also it's an addition, superimposition of this sine x by x function, and this term over is a constant. So what I've done in this case is assume this to be 10, and then I've plotted this function out. So you can see that this function has a periodicity of GA, so it looks like this sine, it looks like this, and it has the superimposition of this cos x function, and then sine x by x function. So you see that it has this shape like this. So if I vary my energy, this function would essentially look like this. While on the left hand side, I have essentially a function which is a cosine function. So this always has to be between 1 and -1. So what I see is that again, I hit this eureka moment. So what I clearly see over here is that there's only certain value of energies which are allowed, because my cosine function has to be between this 0 and 1. So what I get is those values of GA, or those values of energy which result in essentially this function being between -1 and 1. Those are allowed. So these values of energies are the values of energy which result in this function being in this band, they're allowed, while these values which result in these function going out of these band, these are not allowed. And I could rearrange this equation such that I get a more simpler looking functions which relates essentially my allowed energy for a given value of k. So what I get in that case is that if I look back again and replot that function as what are the energies which are allowed for a given value of k. So we see that for this value of k over here, I'm allowed these set of energies, but if my k is between this and this value, then I'm allowed these set of energies. And what I clearly see is that I get these forbidden regions, or I'm getting these forbidden energy levels which I am not allowed. So this was my solution. If I don't have any, if I have free particles, so it was allowed to have any energy. While if I introduce this block function, I introduce this periodicity in my potential, what I'm getting now is that I'm starting to see these forbidden region arise. So I'm seeing these certain values of energies are allowed and certain values are not allowed, and I'm again trying to see this band structure emerge from this Kronig Penney model.